when you're predicting products, you can do this. You can predict the products. What you want to do, first step, leave the positives in the front in the products. So notice that here's our calcium and here's our calcium. So we leave him in the front. And I'm leaving the silvers in the front. Okay, so we did that step. Then it says switch the negatives, or the positives if they aren't negatives. Well, there's negatives here, so switch them. So we're going to put this guy, we're going to put this guy and this guy. So you're switching where they are. So notice that you put the NO3 right here and you put the Cl over here. Okay, step 3, balance each product internally. So the reason this is crossed out is because this is +2 and this is -1 when you look it up. So your NO3 group needs 2. And we look at this guy, he's +1 and -1. That one's okay. How'd you know he was +1? We're going to go back over this side. If you weren't sure, he's +1 to -1. And if you weren't sure, that's -2 to -1. With the transition metals, if you figure out the charge on the left, it doesn't change in a double displacement when you go to the right. It does in a single. We don't have any examples of those. And then it says to balance the reaction on top of everything. Okay, so what you have is CaNO3. And remember, I'm looking for something that has a pair on it. So there's the 2. I'm going to put a 2 in front here. So now my Ag needs to be fixed, which means my chlorines, they're at 2, that's good, and my calciums are good. So this is one of my my products, and this is my other product, and it's balanced. So I'm going to show you another example of these, and then I'm going to pause and let you be able to work on them. So remember, I'm writing these as this HOH for now. So in this case, remember it says if there aren't 2 negatives, so you switch unless there aren't, you can switch the positives. What this means is that, just like before, these 2 spots change places. It's just there's nothing in this spot, so it just means that the place after the H doesn't have anything. So this is an OH group. And I may or may not need that parentheses. Then this step, balance each product internally. So calcium is +2, OH is -1, so I need a total of 2 of those. And then, is everything okay with this H? It's not. This is diatomic, so you might even add in right here, also check for diatomics. Now I'm going to pause, and you guys go ahead and finish these products. Okay, so I'm going to be switching, in this case, this with this. Those are the 2 that are switching spots. So, PB, Cl, and NO3. Now, you can't skip this next step. You have to balance it internally. So look, this group was -1, this group was -1, this was a +1. And because there were 2 of those, that means that your lead was +2. So they keep the same charges on the right-hand side. +2, -1, +1, -1. So I need 2 here. So now that is internally balanced. I'm going to do the next one. So this is a whole group. Try to keep it as a group and try to keep this as a group. You'll notice I'm not bringing the little numbers along unless they're part of the polyatomic ion. That's super important. I'm not bringing this 2 along. So down here I am bringing the 4, but I'm not bringing the outside numbers with it. So everything's in the same spots, my positive and right spots. I'm just going to switch where these 2 groups are. So I'm putting a OH here, and then I'm doing an SO4 here. Now I have to make sure that it's correctly balanced. So this is +1. And this is -2, and that makes sense because that's why there were 2 of those. This is +1, and this is -1. This is +1, this is -1. This is +1, this is -2. So I need a 2 right here. And then last but not least, this one. So we're keeping the positives in the places and we're switching where the negatives are. There aren't any positives. I guess that's okay. We're just switching the negative positions. So this becomes Cl and this becomes F. Now that quick internal check, this is the +1, -1. And then over here, +1, -1. And then I ask, is there anything diatomic? Yes, he's diatomic. Now, if you miss this, you want to go back and balance them. So we'll go back up and we'll balance these 4. I'm looking for a 2. The first 2 I see is with my OH group. So I'm going to put a 2 in front. And that gives me 2 H's, which I have 2 H's. That's good. Everything's balanced. The next one, I'm looking for a 2. I see that in O32 right away. So I'm going to work on fixing that one. So I need a 2 in front here. That affects my sodium, so I'm going to go over and put a 2 in front of the sodium, which affects my chlorine. I'm going to go back over. Oh, my chlorine already has 2. That's cool. And my lead already is good. That one's good. And then the next one, I got a 2 in front here because I already glanced over and I saw this. I don't know if you saw that yet, but I saw the 2 and I thought I'm going to do that one. And that affects my OHs, and notice that this is an OH group right here, so I need a 2 there. And let's see, so that affects my H's, but I've got 2 H's, so I'm good, and my SO4 group is good. All right. Now I'm going to look for a 2. Here's a 2 right there. So I'll put a 2 here. That fixed my chlorine, and now I need to fix my sodium. And then that's my sodium, so I got to check my fluorine. Ah, he's good. All right, I'm balanced. If you get really weird numbers for anything that isn't one of those combustion reactions we did earlier with the plus oxygen making the water and carbon dioxide. If you get really big numbers, be aware you might just need to erase and start over. Usually that's better than trying to keep on fixing yourself. So this is the end of the section for this video right here. There'll be plenty of opportunities to continue practicing your balancing, and the Newton 7.1 and 7.4 is what that's all about.